Today's lesson is 10-7, the area of circles and sectors. So the area of circles and the area of sectors of circles. Your notes today are going to have vocabulary on the top and then 4 examples at the bottom. So what's the difference between the area of a circle and the area of a sector? If you find the area of a circle, you're finding the area of the entire portion of the circle. If you're finding the area of a sector, then you're only finding the area of a part of the circle, so only this piece. So what's the difference in the procedure? Well, the area of a circle is found by pi times the radius squared. So that's a formula to find the total area. And I'm going to put a little total down here. So if you wanted to find the total area, you would just multiply the radius squared, so the radius times itself, and then times pi. If you wanted to find the area of a sector, I'm going to write area of a sector, which is just a piece of the circle, you would multiply the fraction of the circle, so half of a circle, a quarter of the circle, times, I can tell I need a little space here, so I'm going to move this over. So you'd multiply by the fraction of the circle times the total area of the circle. So the fraction of the circle times the total area of the circle. What I'd like you to do now is pause the video and please copy down all of these 4 examples in your 4 spots. And when you're ready to go through these 4 examples, unpause the video. The first thing I'm going to do for example 1 is read the directions. It says, find the area of the circle. In this case, they're asking me to find the total area. And the total area is going to be this entire section in here. So the total area is pi times the radius squared. So I'm going to look at my diagram and find the radius. The radius is a line that goes from the center of the circle to the edge. So in this case, my radius is 12. So my total area is pi times 12 squared, or pi times 144. Now you could multiply by an approximation of pi. Now you guys know that pi is 3.14. And usually you put an equal sign here, but truly pi is approximately 3.14. That means it's an estimation. It's also known as the fraction 22/7, but again, that's an approximation. So what we're going to do to keep this as exact as possible is you're just going to leave this in terms of pi. So this is a really exact answer right here. Area is 144 pi inches squared. So we're not going to multiply by an estimate, we're just going to leave it in terms of pi. For example 2, they're asking us to find the area of the shaded area, in this case only this part of the circle. And that automatically makes me recall this formula. So I'm going to have to find first the fraction of the circle that this section represents, and then I'm going to have to find the total area. So those are 2 things I'm going to have to find, and then I'm going to multiply them together. So let's start by finding the fraction of the circle. When I look at this section, I have to ask myself, how much of the circle is it? So this portion right here is directly related to the central angle that it creates. Now this is a right angle, and because this is a straight line, I know this is a right angle also. That means that this pink section right here, it represents 90 degrees of 360 degrees. Now if I simplify that, divide by 10, and then divide by 9, 90 degrees of 360 represents 1/4 of the circle. And that's the value that's going to go in here. The second thing I'll need to find is the total area. So the total area is pi times the radius squared. Now the radius, remember, is a section of the line that goes from the center to any edge. Now what they've given us, 8 meters, is actually the diameter. So if I wanted to find the radius, it would be half of that. In this case, it's 4. So this is pi times the radius squared, or 16 pi meters squared. Now I have to actually find just the area of this sector. So what's that going to look like? I'm going to change colors here so you know I'm doing my final math here. So here we go. Let me move this guy over. Oh, I can't move it. Okay, anyway, here we go. So the area of the sector, I'll just write it again, is the fraction of the circle, 1/4, times the total area, which is 16 pi. Now when I multiply that, I'm going to multiply across, and there's an invisible 1 here underneath. So 16 times 1 is 16, and then my pi, and 4 times 1 is 4, and I can simplify that to 4 pi. And remember, this is still an area, so it's still meters squared. Now this makes sense. The total area is 16 pi, and the area of just this piece should be less than that, and that makes sense. It's 4 pi meters squared. So the area of the shaded part is 4 pi meters squared. This question is related to example 2, but a little trickier. Now the first thing I'm going to do is read the directions. It would say, find the area of the entire circle. They're asking us to find the total area. Now here's what's given. They gave us this diagram. I know that this section, this little piece right here, represents 30 degrees out of a total of 360 degrees. And they gave me the area of just this shaded piece. What we're going to do is we're going to take all of our given information and plug it in here to try to find the total area. So let's kind of collect some information here. Do I have the area of the sector? Yeah, I do. The area of the sector is up here. So I'm going to go ahead and plug that in. 12 pi is the area of the sector. Okay, that equals. Do I have the fraction of the circle? Yeah, I do. The fraction of the circle is it's 30 degrees out of 360 degrees. Let's find the fraction. Divide by 10. 3 over 36, divide by 3, well, it represents 1/12. Okay, so the fraction of my circle is 1/12. The only thing I don't know is the total area. Well, let's find it. Let's solve for the total area. So here we go. Now I'm going to go ahead and simplify this just a little bit, or maybe I'm going to complicate it. I'm going to say that the total area is the same thing as pi times the radius squared. And what I'm going to do is I'm going to find the radius. Let's see what happens. Now if I divide by pi on both sides, divide by pi, my pi's are going to become 1. So I end up with 12 equals 1/12 times the radius squared. Now my goal is to get radius squared by itself. So I'm going to multiply by 12 on both sides. And when I do that, I get radius squared equals 144. Obviously the radius is 12. Now from here I can easily find the total area. The total area is pi times the radius squared, or pi times 12 squared. So my area total is 144 pi. And this is my final answer. This last question is the trickiest of all. The question says, find the area of the shaded area. Shaded area, it must be an area of a sector. But then when I look at this little shaded piece right here, gosh, that doesn't look like a sector at all. So the first thing we're going to have to do is come up with a plan. So here's my idea. The first thing I would suggest you do is find the area of the sector. And the sector I'm talking about is this green piece right here. You see it? Now, this green piece, if I found the area of the sector, it would represent this whole piece right here. So it would be like this whole pizza. And the pizza looks like this. The second thing I would do is I would find the area of the triangle. So here I'm talking about this right here. The very last thing I would do, and I guess I'll do this in blue, the last thing I would do is I would take the area of the sector and I'm going to subtract it from the area of the triangle. Triangle. Okay, So when I take the pink away from the green, I'm going to be left with just the crust of this pizza, or the area of the shaded part. So let me walk you through this, and I am going to color code it, so I hope that helps. Let me make this a little bit smaller so I've got some space. Okay, I'm going to start with my bright green. So the first thing I need to do is find the area of the sector. Okay, so the area of the sector is the fraction of the circle times the total area. So let's find that. So the area of the sector is, oh man, what's this angle here? Okay, now I know it's hard to see right now, and I really need you to think about this, but this right here is an equilateral triangle. And equilateral triangles have all the same angles, 60-degree angles. That means that this is 60 degrees out of 360 degrees times the total area, pi, times the radius is 12 squared. That means the area is 1/6 times 144 pi. And remember, this is the area of this sector. Now when you multiply 1 times 144 pi and divide by 6, I'm going to cut to the chase here, you're going to get 24 pi meters squared. So this is the area of the green pizza. The second thing we're going to need to do, and I'm going to move this into pink, and I am running out of space again. The second thing I need to do is to find the area of the triangle. The area of the triangle is base times height divided by 2. So I'm going to have to look at my triangle, and I'm actually going to draw it again so you can see it. It looks like this. So this is 12, this is 12, this is 12, and there's a height drawn, and it says 6 square root 3. So let's find the area of the triangle. I'm going to call it area, and I'll just put try here because it's too much to write. My base is 12, my height is 6 square root 3, and I'm going to divide by 2. That's 12 times 6, that's 72, square root 3 over 2, or 36 square root 3 meters squared. And that is the area of the triangle. So let's recap what we've done so far. We found the area of the whole pizza, the green piece. We found the area of the triangle, that's this pink portion. And now my last part is to subtract the 2 to find the area of just the crust. So I'm going to take the area of the sector, 24 pi, and I'm going to take the area of the triangle, 36 square root 3, and I'm going to subtract them. Now remember, when I look at these two numbers, I have to ask myself, are they like, as we say in algebra, are they like terms? Well, this one has a pi, and this one has a square root 3. These can't be combined. So believe it or not, this right here is the area of the crust of the shaded area. This is the answer.